Now I want to show you something that's kind of tricky to understand a little bit. So I have an equation that says y equals -3. And I want to graph that. So let's go through this thought experiment a little bit with me. Let's go through and draw an XY table. And let's choose some values for x. The ones I like, again, are usually -1, 0, and 1. So in this equation, let's solve for y. So if x equals -1, what's y? Yeah, I know what you're kind of thinking. Wait a minute, Willie. That doesn't make sense. There is no x in here. So if that's the case, then what's y? -3. What about the point x equals 0? Well, there's no x in there, but that doesn't change what the value of y is. That's also -3. What about if I set x equals to 1? Same thing. There's no x in the equation. I don't substitute that in. I solve the equation and get 3. So let's graph this out a little bit. Maybe that'll help make sense of it. So at the point of x equals -1, what's my y value? Y is down to -3. If x is 0, what's my y value? -3. If x is 1, what's my y value? -3. Basically, it doesn't matter what my x value is. My y will always be a -3. And what that does then is that produces a horizontal line at the point y equals -3 everywhere. So it doesn't matter what x is. Y will always be -3. So I can graph an equation where it looks like the solution is just a number. And it is. But I need to identify this number, -3, at every possible value of x. So that's why rather than just having a point at -3, I have a line that expands out in both directions. So that's what the equation of a horizontal line looks like.